In the previous three videos, we looked at angles, and the idea was that angles are formed when you consider two lines. So the next natural step is to think, well, what happens if I look at three lines? Yeah. Now, if you were to try to draw three lines in all possible ways, there would be one of these three cases. You can either draw them all to be parallel to each other, which is really not very interesting. The second is you can draw two to be parallel and a third to be not parallel, which we've already covered. Recall that in this case, your opposite angles are equal, your alternate angles are equal, and so on. And this is called the transversal. So that leaves us with the last interesting case, which is what happens when these three lines, no pair are parallel. So no pair, I guess, is parallel. When this happens, what you get is you get a bounded region. Yeah, you get a region. And this region is called a triangle. Yeah. So we label this triangle as ABC and we name it using this symbol, which is a triangle. So we say triangle. We read this as triangle ABC. Triangle because there are three angles. So the characteristic properties of a triangle, there are two types. There are lengths or sides, right? We call these sides AP, BC, and AC, the three sides. And then you have angles. Now we can call them angle A, angle B, angle C. Now because in this case there is no ambiguity, I can use the one letter notation. For this to be angle A, this to be angle B, and this to be angle C. Which means that if I know three lengths and I know the three angles, it completely characterizes a triangle. So now that we know these properties, or the basic properties of a triangle, we'll see that they can be classified. Again, if you have not yet done, you would want to pause the video and look at your book for the definitions of these triangles. Equilateral means all sides are equal. And it so happens that as a result of this, hence all angles are equal to. Now one way to write that or denote that in a figure is by using one dashed line on all three sides. This means that all of these three sides are equal. Similarly, for angles, we can use a double line to indicate that all three angles are also equal. Isosceles, two sides are equal. So let's say these two sides are equal, and as a result of that, these two angles are also equal. Scalene, no two sides are equal. So a triangle like that. So I'm not going to put any dashed line because all the lengths are different. And a right triangle, which again, remember, this box means that this is 90 degrees. The right triangle means that one of the angles is 90 degrees. Now you don't care about the remaining two, but one of them is 90 degrees. Now here's a side activity. Draw any triangle and you measure angle 1, 2, 3, where let's say I call these angle 1, angle 2, and angle 3. What you're going to find is that they always add up to 180 degrees. Okay, that's a very useful property that we have for a triangle. Let's look at an example. Here is a cross-section or a simplified diagram of a roof truss, and you're asked to find this missing angle 4. And a bunch of other angles are given. So you may pause the video right now and sort of think about how to approach this. Now here's the idea. Now if you look at triangle CEF, right, you know that angle 4 plus 64 degrees plus, let's say I call this angle 1. Angle 1 should equal 180 degrees. Why? Because it's a sum of angles of a triangle. Again, solving this gives me 180 minus 64, or I get angle 4 plus angle 1 equals 116 degrees, right? Yeah. Okay. So from here, I get the idea that if this is what I'm interested in, I need this. So now let's further look how I can find 1. I notice that if I label this angle as say angle 2, then I have that angle 1 plus 58 degrees plus angle 2 is 180 degrees. Why? Because it's a straight angle. Or the other term we have learned for this is supplementary. Once again, I get that angle 1 plus angle 2 is 180 minus 58 degrees, or angle 1 plus angle 2 is 122 degrees. Again, remember, we needed angle 1, so we can get angle 1 if we can find angle 2. So now let's further think about how I can find angle 2. Now I observe that I have this triangle ADE, and in this 43 degrees plus this box here means it's 90 degrees plus angle 2 should equal 180. Why? Because it's a triangle. Or 43 plus 90 is 133 plus angle 2 is 180. So what I get is angle 2 is 180 minus 133, or angle 2 is 47 degrees. Now this is good news. Since I have angle 2, now I can find angle 1, because angle 1 is 122 degrees minus 47 degrees. And how much is that? That is 75 degrees. Which is further good news, because then I know angle 4 is 116 degrees minus angle 1, which is 75 degrees. So that angle 4 is now 41 degrees. And then I'm going to box this because that is the thing that I was trying to find. Now this is a method that I would like you to follow for most of your problems. Is you start, well, what do I need to find? Find one relationship that it has with any other unknown. Then you figure out that, well, I need angle 1. Let's see what I know about angle 1. Then you find that I need angle 2. And then let's see what I know about angle 2. Or if I can find 2, then I can find 1, and from 1 I can find 4. Okay, in the next video I'm going to look at some more examples.